Hi, my name is Muhammad Arif bin ALZARI and my group member Muhammad ZAFRAN bin ZAINUZZAMIN and Muhammad HARIZ ISWAN bin SINUIN from group 13. In this video, I'm gonna show you about APSK modulation and demodulation using MATLAB code simulation. First, let's see the introduction. What is amplitude phase shift keying? APSK is a digital modulation scheme that converts the data by modulating both the amplitude and the phase of a carrier wave. In other words, it combines both amplitude shift keying ASK and phase shift keying PSK. This allows for a lower bit error rate for a given modulation order and signal to noise ratio. Quadrature amplitude modulation can be considered a subset of APSK because all QAM schemes modulate both the amplitude and phase of the carrier. Conventionally, QAM constellations are rectangular and APSK constellations are circular. However, this is not always the case. The distinction between the two is in the production. QAM is produced from two orthogonal signals. The advantage of APSK over conventional QAM is a lower number of possible amplitude levels and therefore a lower peak to average power ratio. The resilience of APSK to amplifier and channel non-linearities afforded by its low PAPR have made it especially attractive for satellite communication. Next, constellations plot output. There are many APSK constellations. Circular constellations are the most common. There may be multiple circular constellations of the same order. For example, 16 APSK could be implemented using a 1-5-10 constellation or a 5-11 constellation. Increasing the number of rings decrease the bit error rate but increase the PAPR. Other APSK constellations include triangular, rectangular, and hexagonal constellation.
Hi, Assalamualaikum. My name is ZAFRAN and now I want to present about result for amplitude phase shift keying. This is our result for apply APSK modulation. And this one is our coding for APSK modulation, and this is our scatter plot. And now I will explain about the coding. Y equal APSK mod XM ready performs APSK modulation on the input data X based on the specified number of constellation point per PSK ring M and the radius of PSK ring radii. Next, for apply APSK modulation with phase offset, we have to modulate a random data sequence using APSK with 0 phase offset for the inner circle and pi/6 phase offset for the outer circle. This is our code for APSK modulation with phase offset, and this is our scatter plot. Next, for the coding, the Y equal APSK mode XM ready phase offset specify an initial phase offset for each PSK ring of the APSK modulated signal. Next, for apply APSK modulation modifying symbol ordering, we have to put constellation for gray and custom symbol mapping. And this is our code for gray map, and this is our quadrature graph. For the coding, the APSK mode function assumes the single channel binary input is left MSB aligned and specify column wise. We have to reshape the bit matrix to express the single channel signal in a single column. and then we apply APSK modulation to the data using default phase offset, since the element values for M are equal and element values for phase offset are equal. The symbol mapping defaults to gray. Binary input is used to highlight the gray nature of the constellation mapping. And this is our custom map. For custom map, we have to apply APSK modulation with a custom symbol mapping. Plot the constellation. Binary input is used to highlight the custom mapping defines different gray symbol mapping. Also, we have to create a custom symbol mapping vector. This custom mapping happens to be another gray mapping. This is our coding, and this is our quadrature graph. Thank you.
Next, apply APSK modulation to input bits. So the purpose for this modulation is to modulate a random bit sequence using APSK and output data type single, and then pass the signal through a noisy channel and display the constellation diagram. So firstly, we must to define the vector for modulation order and PSK ring radian, and then generate random binary data. So if you can see here, the constellation is M equal 8, 12, 20 and 24. And then the radian for each constellation is 0.8, 1.2, 2, 2.5. And then use the code bit per system equal log to sum. So declare the x randy 01 2000 times bits per system and 1, and y equals to APSK mode xm ready, and the title is input type bits output data type single, then yrect equal to awgn y25, and then the title is measure. Then use a code scatter plot in bracket yrect. So the graph, the scatter plot graph will appear like this lah.
Hi, I am HARIZ. I am gonna explain about the demodulated 16 APSK signal. So the signal has an unequal number of constellation points on each side. Define vector for modulation order and PSK ring ready. Generate random 16 array data symbol. So in the code, M equal to 4, 12. The ready is equal 1, 2. The mode order is the sum of the M, which is 4, 12. X is equal ready 0 mode order minus 1, 1000, 1. So next is apply APSK modulation to the data. The X signal equal APSK mode is in column X, M, ready. So for the pass the modulated signal through a noisy channel is SNR equal 20 is equal in dB. RX signal equal AWG in column the X signal SNR that bit measure. So next is the plot transmitted. So this is the reference. Plot column RX signal B, hole is on, grid plot in column TX signal R plus, X lim is in column -3, 3, Y lim in column also -3, 3, X label is in phase, Y label is quadrature, and legend receive constellation, reference constellation. So this is what we get on the MATLAB when we execute the code. Okay, after that, the demodulated signal and compare to the input data, is Z equal APSK demodulation, and in column Rx signal, M, ready, and is equal X and Y, and the answer should be equal logical 1. So the next is demodulated 64 APSK custom symbol map signal. So the signal with custom symbol mapping. Compute hard decision bit output and verify the input, match the output. So define vector for modulation order and PSK ring ready. Generate 100 symbol of random bit input. So for the code is M equal 8, 12, 16, 28 in for PSK circle. So the mode order equals sum of M. The ready equal 0.5, 1, 1.3, 2. The X equal the ready column 0, 1, 100 times with log 2 column mode order, 1. So next is the create a custom symbol mapping vector for binary mapping. CMap equal the ratio of 0, 63. Next is the modulated the data and plot the constellation. Okay, for the code is Y equal APSK mod column X M ready symbol mapping CMap input type it plot constellation, true. So after that we will get the custom map as shown with coder through amplitude. Okay, next the demodulated receive signal. For the code is Z APSK mode Y, M, ready symbol mapping CMap output type, bit. Next is to verify the demodulated signal is equal to the original signal. IS equal XY, answer should be equal logical. Alright, for the last one is soft bit demodulated 32 APSK signal. So it produces demodulated signal and calculates soft bits. Define vector for modulation order PSK ring ready and generate 10,000 symbol of random bits data. So for the code is M equal to 16, 16. Mode order equals sum M. Ready equal 0.6, 1.2. Number of symbol is 10,000. X equal ready 0, 1. Number symbol log 2. Mode order, 1. So this is for the generate reference constellation. First is reference APSK equal APSK mode in column 0, 0 mode order -1, M, ready. Constant diagram APSK equal dot constellation diagram in column reference constellation ref APSK, title, receive symbol, X limit, -2, 2, Y limits, -2, 2. Next is for the modulated data. TX signal equal APSK mode in column X, M, ready, input type, bit, and the signal power is equal variable column TX signal. Next is for the pass signal through noisy channel. S and R equal 15, RX signal equal AWG, and in column TX signal, S and R, signal power, linear. So for the plot reference, receive constellation symbol, constant diagram APSK, in column RX signal. So we will get the plot measurement is this. Okay, next is the demodulated signal and complete soft bits. Z equal APSK demode in column RX signal, M, ready, output type, approx LLR, noise variance, signal power, /SNR code. And that's all. Thank you.
As the conclusion, ASK, FSK, and PSK provide limited data throughput. Combining amplitude and phase modulation allow much higher bit rates. APSK adds amplitude state to PSK, more widely spaced symbols, primarily used in satellite application. QAM also use amplitude and phase shift based on IQ modulation, very high order bit rate achievable, used in most modern communication technology. It's all from us, and thank you.